Okay, comparing two means, that's what we're going to talk about today. Who smiles more, humans or aliens? Researchers equipped random samples of 72 humans and 32 aliens of the thousands freed from Area 51 during the rally with smile sensors. They recorded the number of smiles for each over a random selection of 5 days out of a month and calculated the average number of smiles per day for each subject. The human estimates had a mean of 6,751 smiles per day, with a standard deviation of 2,812 smiles, and the alien estimates had a mean of 6,298 smiles per day, with a standard deviation of 2,051 smiles. Do these data provide convincing evidence of a difference in the average number of smiles per day by humans and aliens? Okay, so we're going to compare two means here. So let's go ahead and shrink this up real quick. Make this just a mite bit smaller and out of our way. And let's go ahead and see what we've got to add first. Do these data provide convincing evidence of a difference? So we're going to do the difference of two means. Notice this is numeric data. So we're dealing with means and not proportions. So the first thing we want to do is let's define our two means. We're going to talk about mu sub 1, which is going to equal the mean number of smiles per day for humans. And mean sub 2, or mu sub 2, is going to be the mean number of smiles per day for aliens. Okay? So, there's our first part. And we already know what those are. We know for humans it was 6,751, I believe. 6,751. And for the aliens, it was 6,298. 6,298. So those were the means. Now, what are our hypotheses? We have the null hypothesis, which is that there would be no difference. That mu sub 1 is equal to mu sub 2. Or in other words, mu sub 1 minus mu sub 2 is equal to 0. So again, we get the alternative hypothesis, and that is, actually I'm going to make those little colons, that is that it is different. Mu sub 1 is not equal to mu sub 2. Now again, remember this question was, do these data provide convincing evidence of a difference? Not that one is higher or lower than the other. This is simply that they are different. Okay? So if we wanted to go with this route, we would also say that their subtraction was not equal to 0. Okay? So what does this allow us to do? Well, this allows us to now move on to our assumptions and conditions. So let's go ahead and do that. Let's change color here. What's the first one always that we're going to do? Random, right. And we've got random samples right there. So let's go ahead and we underlined it, random samples. Quote. Random. Check. You got that one. What's the next one? For all of our tests, we always do random, and we always do, if we're doing without replacement, right, 10% rule. So let's see. 72, so n sub 1 is equal to 72, and that is definitely less than all humans, for sure. All humans. And then sample size 2, n sub 2, was 32. Now we're going to make the assumption that that is less than all aliens out there in the universe. All aliens. But we don't know. We only let a couple of thousand go from the Area 51 rally, right? Anyways, so let's assume if there's at least a couple thousand, there's more than 320 aliens roaming around, let's say, if the rally was successful. So anyways, what's the third one we do? The third one depends on if it's proportions or means. Now remember, this isn't proportions. We're dealing with means up here. We have numbers, numeric data. So what we have to deal with is normality or large samples. Now, are our samples large enough? Yes, they had to be greater than 30, and they both are. So we don't have to plot and show normality. If either one of these was less than 30, we would have to show a plot and show the normality for that, and then we could move forward. So let's go ahead and say n sub 1 equals 72, which is, of course, greater than or equal to 30, and n sub 2 equals 32, which is greater than or equal to 30. So again, this is our large samples. Large samples. Check. And over here, I'll put 10%. Check. So now we've got our conditions and assumptions. What test does this allow us to do? We have two samples, two means to deal with. So yes, this is in fact a two-sample t-test. So let's go ahead and say that. We have a two-sample t-test. Now, why is it t and not z? Right. It would have been z if we knew the population standard deviation for the means. But since we don't, we have to use the estimate standard deviations, and that leads us to have to deal with t star when it comes to means. Okay, so we've got those two parts. Let's go ahead and move on from here. And what I'm going to do again, let's go ahead and shrink this on up so that we can have a little bit more space. We'll just move that on out of the way a little bit. Hope you can still see that somewhat if we need to go back to it. But now let's go ahead and start to do some calculations. So, first thing we want to check, how many degrees of freedom do we have? So degrees of freedom. Well, we know that that's n minus 1, but we have to do the smaller of n minus 1 or n sub 2 minus 1. So which is it? 72 minus 1 or 32? Yeah, you got it right there. It's going to be 32 minus 1, which is 31 degrees of freedom. Now, at this point, I want you to go look at your table. Because remember, on the AP test, we're going to be doing free response questions for this probably. So you have to be able to show the work, not use the calculator. We'll use the calculator to check this, but I want you to know how to do it by hand. So get out your t-table. Go ahead and pause the video right now and get your t-table. I'm pausing, but I don't really need to because you just unpaused it and you have your t-table right now, right? Okay, good. If you didn't, go get your t-table. Why aren't you doing it? Go get your t-table. Pause. It's easy. I won't go anywhere if you pause me. Okay, so if you go to your t-table, what we're doing is we need to find out, gosh, what are we doing at our t-table? We need to figure out what our t value is. So we still have to find that, but you needed our t-table. I want to make sure you got that. Let's go ahead and find our t value now. So let me go ahead and put that. This is like the z value, remember, but it's t. So we're going to have a fraction. We're going to have our data value of interest minus the mean, or in other words, for us, the difference, which is our 6,751 minus 6,298. Let me double check that. Minus the mean. And we're assuming the mean is nothing, no difference. So it's minus 0, divided by the standard deviation, or in this case, the standard error. Actually, it has to be standard error. That's why we're doing t, right? So remember, this is two samples. So we're going to have two things to put here. We're going to take our mean for the first one, 6,751, and we're going to square it. And then we're going to divide it by the sample size, 72. Then we're going to do the same thing with the alien data, which is 6,298 squared divided by its sample size of 32. When we do this, we get a value, well, actually I can tell you pretty much the exact number because I've got it here. It's 0.92222 5 4, 1, 5, 7, dot, 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 blah, blah, blah. So we're going to estimate that at approximately 0.922. And I'm going to 3 decimal places because you'll notice on your t table, the t table values go to 3 decimal places. So that's why I'm going to 3 decimal places here. Now, if we use technology, believe it or not, we get a t value almost exactly the same. So, what do? Go take a look at your table. How many degrees of freedom do we have? Right, we have 31 degrees of freedom, but 31's not on the table, is it? So, we are going to use 30 degrees of freedom from table. Okay. And how do we do that? Well, go down the left-hand side on the degrees of freedom, get to the 30, and then go over until you find the range where our t value would be. Our t value is 0.922. So how far over do you go to get between that? So you've got the 2 numbers on both sides. Right, you'll notice 0.854 to 1.055 contains our t value. So let me go ahead and put that. Where's my pen? 0.854 to 1.055. Now that's where we see the range that contains our 0.922. Now look up above on the table. 0.854, if you go all the way to the top, that corresponds with 0.20 or 20%. Go to the 1.055 column and go all the way up, and what do you get to? 0.15, or in other words, 15%. So what's going on here? Let's draw a picture really quickly. What we found, we have a relatively normal t table. Here would be our mean of 0. We found a t value of 0.922. So let's go over here, 0.922. So what's the probability that it's more extreme than that? So the probability that it's more extreme than that is from 20 to 15, or the other way around, from 15 to 20%. But that's a one-tailed test, isn't it? We've got to remember we're doing a two-tailed test because we were looking right back here that it's just not different. They're not the same. They're not equal. So we've got to include this amount as well. So let's double these. We have to double our percentage times 2. So really, we're going to say that it's between 40% and 30%. That's our p-value. So remember, with the t-table, you don't find the exact p-value, you find the range for it. And we had to double it this time because we have a two-sided test here. So, do we reject the null or not? Well, if an alpha level is 5%, we would say, let's go over here, because the p-value, I'm going to say what it is, 40 to 30%, because the p-value is greater than alpha value, which equals 0.05, we fail to reject the null. Okay? We fail to reject the null. In other words, there's not convincing evidence that humans and aliens smile at different rates per day. Okay, now, we've done a hypothesis test for it. Let's do a confidence interval for the same situation. Okay, so I'm going to jump to the other page really quick, and I'm going to remind us how a confidence interval sets up. We want to remember that for the difference, we're going to take mu sub 1 minus mu sub 2. Make that there. And that's our data value of interest. Plus or minus our t star times our standard error of that difference, mu sub 1 minus mu sub 2. So that's the calculation, that's the setup for all of these, basically. So for this particular situation, what do we have? Well, mu sub 1, that was 6,751. 6,751. Mu sub 2 was 6,298, plus or minus. Now, t star, how do we get t star? Well, we have to remember, how many degrees of freedom do we have? So over here to the side, I'm going to remind us, degrees of freedom, n minus 1. But we have to do the smaller of the two. So in this case, it's going to be 32 minus 1, or in other words, 31 degrees of freedom. 31 is not on the table, so we're going to use 30 degrees of freedom from the table. So let's go do that. And we're going to find that t star equals what? So go to 30 degrees of freedom, and then what confidence interval are we going to do that corresponds with a alpha level of 5% of a two-tailed test? So remember, if the alpha level is 5%, that had to mean 2.5% on each side. So 2.5% really means we're talking about 2.5% on each side, a 95% confidence interval for the two-sided test. Okay? So what you're going to do is at 30 degrees of freedom on your T table, go over until you are above the 95% confidence level. When you do that, you'll notice what's the value? Right, 2.042. So 2.042. We're doing the confidence interval manually, so we have to find the t value manually. So now we know it, right? So that's our t star value. We're going to put it right there. So 2.042 times the standard error. We calculated this before. Let's go ahead and rewrite it again. We're going to do our 6,751 squared divided by 72, the sample size, plus the mean here, 6,298 squared divided by its sample size of 32. When you calculate all that out, we end up with negative 550.04 blah, 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 to about 1,456.04 blah, 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 blah. So what does this mean? Well, if we put this into a sentence, like we should, we are 95% confident that the true mean difference between average daily smiles of humans and aliens is approximately negative 550 to 1,456. Meaning, between aliens smiling 550 more times to humans smiling about 1,456 more times on average. So is this consistent with our hypothesis test? Yes, it is. We failed to reject it because we found not enough evidence, and notice that the zero difference is inside of our interval. The number 0 is contained between negative 550 and positive 1456. So we have done a good job. We figured it out. Good job, folks. Now, let's go find those aliens so that we can go ask them this question, right? Talk to you later. Have a good one. See you later. Bye-bye.